Jai Hind everyone. We are on panel number 16 to perform no load and block rotor test on single phase induction motor. So here we have single phase induction motor and DC shunt machine setup. On this setup we are going to have capacitor start, capacitor run type of motor to perform this experiment. To perform this experiment, we are going to use one voltmeter to measure the power in both the condition, in no load condition and in short circuit condition. This will measure the no load current and short circuit current as well. We are going to use this single phase variac to regulate the voltage, to have control on the input voltage. And to measure this voltage, we are using this clamp on meter. So this is about the arrangement of different instruments. If you observe the panel, in the panel we are having this main winding. This main winding is connected with the starting winding. SW means the starting winding. The starting winding is connected with this wire to capacitor. In initial stage, the pointer or the switch will be connected with capacitor start, and as the motor reach to 75 to 80% of rated speed, it will get shifted to capacitor run. This capacitor start and capacitor run, they are connected in parallel with each other. One terminal of this main winding is in parallel with this capacitor. Let us move to the setup. This is the induction motor and DC machine setup. Here the specification of induction machine becomes very important for all of us. Why? Because it shows the value of starting capacitor and running capacitor, and the most important part is the rated capacity of the current. Here we are having 8.4 ampere current, so that it means when we block the rotor, we have to apply the voltage till we reach the value of 8.4 ampere. And the value of voltage is 190 to 210. It means while performing no load test, we can reach or we can perform this experiment up to 210 volt. This motor is of 1.1 kilowatt or 1.5 HP. It shows the single phase motor. 50 hertz is the supply frequency or the rated frequency of the machine. The machine is rated with 1440 RPM and continuous CONT. This means the duty cycle, and the ambient temperature is around 40 on Celsius. Here they have mentioned the value of capacitor. Starting capacitor is around 150 microfarad and the running capacitor is of 10 microfarad. So whatever we have studied in theory session, it is proved now that the value of starting capacitor is higher than the running capacitor. You can observe both the capacitor over here on the machine only. This is the arrangement to provide the cooling, and here we have the DC machine. We can also observe the reading of DC machines. These are the DC machine specification, but right now we are going to allow the rotor to move freely for no load situation, and in the block rotor situation we are going to block the shaft till we reach the rated capacity of the current. So this is about the experimental setup of no load and block rotor test. Now the thing is, why we are performing this test? We are performing this test to calculate the equivalent circuit parameters and to get the different performance parameter of the machine at 5% of sleep. We can find out the efficiency, we can find out the value of torque, we can find out value of XM and so on. Everything is given in your manual for the calculation. So this is what all about the single phase induction motor no load and block rotor test. The performance is the same whatever we have done for 3-phase induction motor no load and block rotor test. This is one of the indirect testing method to calculate the efficiency of single phase induction motor. So now we are performing no load test. Here we have allowed the rotor to move freely. Let us go to the setup. With the help of variac, we kept the value of voltage at 210 volt, which is the rated one. If we observe the voltmeter reading, it is giving 210 watt. The multiplying factor for this is 2, and the value of current is 6.1. So this is for no load test. We can change the value of voltage. We can take 5 different readings for the performance of no load test. But if we want to perform the short circuit test, then let us go for the short circuit test. Now for block rotor test, you can see the way to hold the rotor, and we will apply the voltage till this motor reach to 8.4 ampere. So now we are just applying the value of current, and it is almost 8. Now it is 8.4. And at that time, we have to measure the value of voltage as well as power. So this is all about block rotor test. By blocking the rotor, we are measuring the short circuit power, short circuit current and short circuit voltage. So this is the entire performance of single phase no load and block rotor test.